Hello students, good morning. Welcome to my lecture on chapter number 10, Halogen Derivatives, Class 12 Science, Maharashtra State Board, New Syllabus 2020. In the previous lectures, we have studied about elimination reaction, set-zip rules, word section, etc. in case of what? Alkyl halide. Today we are going to study reaction of haloarenes. So let us start. Be ready with pen and paper. Reactions of haloarenes. They are also called as what? Aryl halides. They can also be shown by what? X. Okay. Now let us start with first reaction, that is reaction with metals. Here we have to study two reactions. First, Worst fitting. Reaction. First of all, this is extension of Worst reactions of alkyl halide, and it is modified by what? Fitting also. So it is called Worst fitting reaction. Now see here what happens. First we will write aryl halide, take sodium metal, dry sodium metal, and one molecule of alkyl halide. This reaction is carried out in presence of dry ether. You know that what happens? This part goes to sodium, and you get what? Substituted aromatic compounds, and it is what? Alkyl substituted, and here you get what? 2NaX. It is what? Aromatic hydrocarbon. Now it is what? Aryl halide. It is what? Sodium metal, alkyl halide. Rx means what? Alkyl halide, and it is called as what? Substituted. What substituted? Alkyl. Alkyl substituted aromatic hydrocarbon. So what is the meaning of Worst fitting reaction? See, the reaction of aryl halide with alkyl halide and sodium metal in presence of dry ether to give alkyl substituted aromatic hydrocarbon is called a Worst fitting reaction. Now see the example. We can take chlorobenzene, it is called chlorobenzene, plus sodium metal, it is dry sodium metal, plus CH3Cl, that is what? Methyl chloride. This reaction is carried out in presence of what? Dry ether. So here you get what? Alkyl group, that is methyl, gets substituted. CH3 plus, so it is chlorine, and it is called as what? Here it is 2NaCl. Now This is the example of Wurtz-Fittig reaction. I hope you understood this reaction. This methyl group replace what? This chlorine, and here it will get the place. Now see second reaction, that is what? Fittig reaction. Here we have to take two molecules of aryl halide. We can take here chlorobenzene, or we can write down this way. Sodium metal. This reaction is also carried out in presence of triethyl. Here what happens? Chlorine combines with sodium to form what? 2NaCl. And here two aromatic rings combine together to form biophenyl. Plus 2NaCl. It is called as what? Biophenyl. Means when two molecules of aryl halide react with or treated with sodium metal in presence of triethyl, biophenyl is formed. This reaction is called as Fittig reaction. I hope you understood reaction with metals. They are very easy to understand and they ask for 1 or 2 marks. Explain Fittig reaction or explain Wurtz-Fittig reaction. Sometimes MCQ also asks on the basis of reaction of halogens with metals. Now we will proceed for second case, second reaction. That is very important. That is nucleophilic substitution reactions. What is nucleophilic substitution reactions? Nucleophilic substitution reactions of halogens. You know the nucleophile. Nucleophile can be shown by what? This way. They are very rich species. See, they are shown by what? Nu. You can consider your hydroxyl ions, then sulfate ions. They are what? Nucleophiles. Means negatively charged ions. They are what? Nucleophiles. Already we have studied about this in the previous lectures. Now we have one question. See this question. The nucleophilic substitution reactions of halogens are more difficult as compared to that of haloalkanes. Haloalkanes means alkyl halides, or we can say aryl halides are less readily undergoes nucleophilic substitution reaction. So we will see the reason. Sometimes we are asked to explain. So come to the solution. There are different reasons. First reason is what? Resonance effect. Resonance effect. Now you know how to draw the resonating structures. First you see this. chlorine. You know the atomic number of chlorine is what? 17. So it contains 7 valence electron. 1 electron is shared here. So chlorine having 3 lone pair of electrons. See 1, 2, 3, 4, 5, 6. What happened here? This chlorine, due to inductive effect, you know that chlorine has the ability to accept electron, but due to resonance, chlorine has the ability to donate this electron. It is because of what? Resonance. So what happens here? This is the first structure. Now see the second. Here what happens? Here there is a formation of bond. Here we have positive charge because this chlorine atom loses 2 electrons to form this double bond. Now here these bonds remain same. Here we get what? Negative charge. See, this position is called as what? Ortho position. Ortho. I am writing here. You remember this. Here chlorine. This position is what? Ortho. It is meta. It is para. It is meta. It is O. Ortho. You remember that. Now again proceed for the next structure. What happens here? You get this type of bonds. Here plus charge. This one. Here you get what? Negative charge. This is para position. Now one more structure we will draw. Now see, there are 4 structures. 1, 2, 3, 4. This first, it's okay. It is what? Ortho position. It is para position. It is again ortho position. What do you observe? See, at ortho position there is negative charge. At para position there is a negative charge. Now what happens here? Due to resonance, what happens? See, these carbon atoms CCl bond have partial double bond character, and you know that double bond is more stable than single bond. So it is strong. So it is very difficult to break this CCl bond as compared to alkyl halide, because alkyl halide contains what? See, CH3, CH2, Cl. This bond is what? Single bond. It is what? Single bond. And see, here it is double bond. So double bond is strong as compared to single bond, and therefore this bond is CCl bond in haloarenes is very strong due to what? Resonance. And so it is very difficult for the haloarenes to undergo nucleophilic substitution reaction. I hope you understood this first point. Now proceed for the second point. You know the question. We are going to study why do haloarenes feel difficult for nucleophilic substitution reaction. Now see the second reason. Different hybrid state of carbon atom. We have what? CH3, CH2, X, or we can say take Cl. Now see, in this This is the first case. That is what alkyl halide. It is alkyl halide and it is aryl halide. In alkyl halide, check the hybrid state of this carbon atom. This carbon atom is attached to 4 sigma bond. 1, 2, 3, 4. It can also be written as what? CH3, C, H, H, Cl. So there are 4 sigma bonds. So this carbon atom is what? sp3 hybridized carbon atom. And here, see here, there is a double bond. This carbon atom, 1. This carbon atom is what? sp2. Why sp2? Because there are 3 sigma bonds. 1, 2 and 3. This is what? Pi bond. So which is the stronger? You know that sp2 is more stronger than sp3. More stronger, more stable or more strong as compared to sp3. And therefore it is very difficult to break this bond. Very difficult for this to break this bond, for to attack or to replace chlorine by another nucleophile. So this is the one reason aryl halide show less reactivity towards nucleophilic substitution reaction. Now see the third reason. That is what? Polarity of CH bond. Polarity of CH or carbon hydrogen bond, or we can say CCl bond. Now what happens here? Again we will take CH3, CH2. We can take again chlorine. This chlorine 1, 2, 3, 4, 5, 6. You know that is 7. And another case is what? Chlorobenzene. Now see, this is the first case and this is the second case. What happens here? Now we can consider this is our father. Now what does father expect? There is an inductive effect. See, father expect more study from the sun. See, it is one way process. But now in chlorobenzene, here halogen is what? Father. What happens here? Father expect more study from the son or daughter. But at the same time, father have to give some gift for that work. This is what? Resonance effect. Resonance effect. Now what happens in resonance effect? Here chlorine has ability to donate electrons. So in chlorobenzene, inductive effect as well as resonance effect both can work together. But due to inductive effect, here polarity is more. So it will break CCl bond easily. But in case of chlorobenzene, what happens? Polarity is reduced. Polarity is less. So it is very difficult to break CCl bond. You know, more polarity, then weaker is the bond. So this is the one reason where aryl halides are less reactive towards nucleophilic substitution reaction. Because of the possible repulsion, it is less likely for the electron rich nucleophile to approach electron rich ions. Now you know that benzene ring is always electron rich. I am writing CH3, CH2, Cl, and here I am writing chlorobenzene. Case 1 and this case 2. Here it is a nucleophile. Now, nucleophile is what? Electron rich, and it is C. Here, electron strongly pulled towards chlorine, so it is electron deficient, and it is electron rich. It depends. Now, question arises: is nucleophile interested to attack alkyl halide or aryl halide? We'll see that. What happens here? See, when this chlorine pulls away these two electrons with it, then this CH2 having got positive charge, and that time it is electron deficient. But here it is always electron rich. Why? Because of resonance effect. Because chlorine is electron rich, as well as this benzene ring is also electron rich. So nucleophile is not interested to attack electron rich aryl halides. So it can easily attack electron deficient group, that is CH3CH2, and this will remove. So therefore aryl halides are less reactive towards nucleophilic substitution reaction. It is not easy for the aryl halides to get attack from nucleophile, because nucleophile is not interested to attack electron rich centers. We know that if there is a distribution of food packets, that time there is a queue of poor peoples, as well as there is a queue of poor peoples, because there is no queue of rich peoples, because rich peoples are not interested in that food packets, because already rich peoples have food packets. So similarly here, nucleophile is not interested to attack electron rich ions. I hope you understood this reason why aryl halides are not interested in nucleophilic attack. There are four reasons. First, we have seen about resonance effect. Second, we have seen about different hybridized states, that is sp2, sp3, etc. You know that. And third one, polarity. And fourth one is what? This electron repulsion. See all this. Observe all these four reactions. See, first of all, I have taken only aryl halides. You know that aryl halides are less reactive towards nucleophilic substitution reactions, and therefore the reactions can take place with a difficulty. Therefore, they require what? Strong conditions. See, the temperature 623 Kelvin and pressure 300 atmospheric pressure. Then only it is possible. But when electron withdrawing group attach to this benzene ring, then see the conditions. See, only one electron, to say NO2 is what? Electron withdrawing group is attached at para position. What happens? See the conditions. Here, conditions: temperature is very low, that is 433 Kelvin. Pressure is not required, and here the substitution reaction take place. See, Cl is replaced by what? OH. Now see this third reaction. Here there are two electron withdrawing group, and observe that their position. Electron withdrawing group must attack at ortho or para position. Here there are two NO2 group. Now conditions are still less strong. Here temperature here 433 Kelvin, but here it is 403 Kelvin, and we require what? Sodium carbonate. Sodium carbonate is less basic than sodium hydroxide. So see, the Cl is replaced by OH. Substitution take place with easily. Now see the fourth reaction. Here there are three NO2 groups. That is three electron withdrawing group. Two at ortho position and one at what? Para position. Now it requires very weak conditions. That is only warm with water. Substitution reaction take place easily. Remember that electron withdrawing group, if attached at meta position, this position, then it will not affect the reaction. It will not carry out nucleophilic substitution reaction. So remember, electron withdrawing group always attached at ortho or para positions. If number of NO2 group, number of electron deuterium group are increases, then we require very weak conditions for the nucleophilic substitution reactions. Thank you very much. I hope you understood this part. In the next lecture, we will study remaining part.